Hi, in this video we will look at halogen displacement reactions using chlorine water, bromine water and iodine solution and the colour changes that can accompany these reactions. Now recall that the halogens are fluorine, chlorine, bromine and iodine, and they are found in group 7 of the periodic table. Now halogen displacement reactions are normally used as a way to work out the order of reactivity of the halogens. But let's cheat a bit here and just say that the most reactive halogen is fluorine and the halogens become less reactive as we go down group 7. Now a halogen displacement reaction is one where a more reactive halogen will kick out or remove a less reactive halogen from its compounds or solutions. As an example, consider the following experiment. Here, 3 boiling tubes are set up and a few mils of potassium chloride, potassium bromide and potassium iodide solutions are placed in each of the boiling tubes. So that is, in each of the boiling tubes there is a halogen present, a chloride, a bromide and an iodide. To carry out a halogen displacement reaction, let's add some chlorine water to each of the boiling tubes and observe any colour changes that take place. Now chlorine water is a very pale green colour. In fact, it's so pale it's almost colourless. On addition of chlorine water to each of the boiling tubes, a bung should be placed in each tube and it should be shaken for a few seconds so that the chemicals can mix and react. The results from this experiment are: the boiling tube with potassium chloride in it shows no change in colour, while the boiling tube with potassium bromide turns yellow, and finally the boiling tube with the potassium iodine in it turns a light brown colour. Now let's have a look at each of the 3 reactions that we just saw in turn and try to work out what was happening in these reactions. In the first reaction, chlorine water was added to a colourless potassium chloride solution and no colour change was observed here. If we have a look at the chemicals that were mixed, we can see that if a chlorine atom from the chlorine water displaces or replaces a chloride ion in the potassium chloride solution, then really no new products will be formed, so really we can say that no reaction is taking place here. In the second reaction, chlorine water was added to a potassium bromide solution and this time a colour change was observed. The solution was found to turn yellow. In this reaction we have 2 halogens present, chlorine from the chlorine water and a bromide ion in the potassium bromide solution. Since chlorine is more reactive than bromine or bromide, the chloride atom will displace the bromide ion from the solution and produce a potassium chloride solution and bromine. It is the presence of bromine dissolved in the solution that causes it to appear yellow in colour. In the third reaction, chlorine water was added to a potassium iodide solution. This time the 2 halogens present are chlorine and iodide. Chlorine is much more reactive than iodine or iodide and it will displace it from the potassium iodide solution to form a potassium chloride solution and iodine. It is the presence of the iodine in the solution that causes it to appear light brown. Now if you need any help with working out the formulas for any of the chemicals involved in these equations, then click the link in the description below. Earlier we used chlorine water to carry out displacement reactions. Well, we can also use bromine water to carry out similar halogen displacement reactions. Now bromine water is made by simply dissolving liquid bromine in water. Dilute solutions of bromine water are yellow in colour and they slowly become orange as their concentration increases. If we try to carry out similar displacement reactions to the ones we saw earlier, but this time using bromine water instead of chlorine water, then what might we expect to see happening? Well, bromine can only displace a halogen lower than it in group 7, that is, it can only displace iodide ions from their salts or solutions. So in the first boiling tube, which contains a potassium chloride solution, The addition of bromine will not be able to displace the chloride ions from the solution, so no reaction will occur. In the second boiling tube, adding bromine water to a potassium bromide solution will result in no new products or substances being made, and as before, no reaction will happen here either. This just leaves the third test tube, which contains a potassium iodide solution. Now, bromine is more reactive than iodide and will be able to displace the iodide from the solution. The displaced iodide ions will form iodine, which will dissolve in the solution and turn it a light brown colour. Iodine dissolves very poorly in water, so iodine solution, which is a brown colour solution, is formed when iodine is dissolved in a potassium iodide solution. So finally, what would be observed if we added iodine solution to boiling tubes containing potassium chloride, potassium bromide and potassium iodide solutions? Now, out of the three halogens we have been using so far, iodine is the least reactive, and it will only be able to displace a halide below it in reactivity from group 7. Now, in the first boiling tube, any added iodine solution will not be able to displace the chloride ion from the potassium chloride solution, simply because the chloride ion is much more reactive, and so no reaction will occur here. Similarly, in the second boiling tube, any added iodine will not be able to displace the more reactive bromide ion, so again, no reaction will take place in this boiling tube. And finally, adding iodine to a potassium iodide solution in the third boiling tube will not result in any new products being formed, and so again, no reaction will take place here. The brown colour of the iodine solution will simply be diluted as it is added to each of the boiling tubes, but no displacement reactions will take place since iodine is the least reactive halogen present. For more information on halogen displacement reactions, why not visit the website that accompanies these videos? Now, it is worth mentioning that some halogen displacement reactions can be carried out using organic solvents such as hexane or cyclohexane. Using these solvents can make it easier to see the colour changes taking place during these reactions. The experimental setup and results using these solvents is covered in the website. Simply click the links in the description below.